The supersymmetric gauge theory is the hard constraints by the conditions of holomorphy and symmetry, and the Lagrangian forms that are determined by the following constraint. And separately, we talk about the various topics in the supersymmetric gauge theory, especially the SQCD as the confinement supersymmetric theory, for example, the ADS superpotential. The superfused and couplings are protected by the non-normalization theorem of the supersymmetry, so that there is no additional perturbative corrections beyond the tree level of one level effect. So, for example, if we consider SQCD of the SUNC case theory, whereas NC is the number of the color and the NF is the blivus of the clock superfield, then we can assign the gauge theory for the left-handed and right-handed superfields that are under global symmetry through with the baryon numbers that are under R symmetry. Then we can include the gauge invariant operators like Amazon and the baryon, which consists of the clock superfield. And depending on the number of the NF and NC, we can construct the theory with the highly constrained imposing conditions. For example, the if NC is larger than NF, then the ADS potential is generated. But there's a no runaway vacuum with the no stable minimum, so that we need to add the curve maximum to penalize the vacuum. If the NF is equal to the NC, the classical modulus path is modified by the quantum mechanically, and the origins are removed. And if the NF is rather than NC, but that just splitting is just number of the one, then as confinement structure. The IR theory is completely discrete by the gauge invariant composite operators, like Amazon and the baryons operators. And there are no remaining gauge degrees of freedom. This is called S confinement. So the potential is uniquely determined. Compared to the ordinary QCD non-supersymmetric theory, the confinement is also effective, but the IR theory is not explicitly known. But in the NF equal to NC plus 1, IR theory is already determined by the superpotentials, so the strongly coupled theory is exactly solvable in the IR theory. The UV theory is given by the SUNC through with the free superfields of the curve Q and Q tilde. But now the IR theory, there are the no gauge interactions. The superpotential is only consist by the meson and the baryons operator. So the by the effective field theory, the curve and the Coulomb fields are now replaced by the meson and the baryons operators in the low end of the IR theory, sort of the super QCD. So that the behavior of the SQCD can be summarized with depending on the NF and NC, like the ADS superpotential, moduli space, complete IR theory, and if the NF is larger or equal to the NC plus 2, then there is a no simple description of the Amazon and the balance operator. So only the third case, NF is equal to the NC plus 1, can give the complete and regular IR effective field theory which satisfies all the following conditions: the confinements, no mass last clone, IR discrete by all the gauge imbalance field like as a confinement bound states, and the smooth modulus path and the local potential exists. So this is called as confinement. But now today I'll talk about if the NF is larger or equal to the NC plus 2, then there is a losses of the degrees of freedom. The meson and the variant descriptions then break down because there are the no potentials of the form with the meson and the variant operator, which is all consistent with the all symmetries and the holomorphism imposing condition. The modulus path of the vacuum expectation value Q and Q tilde as transforms under the gauge symmetry, and this color superfields has a degrees of freedom of the NC times the NF. So the total number of the compact color degree freedom the two NC's NF. And the gauge group SUNC has the dimensions of the NC square minus 1, which is the number of the generators of the gauge group. Then we can identify the configuration space, the size or dimensions of the space, by subtracting this number from the original degrees number prisms minus the number of the generator. Then as the NF increase, the dimensions grow. So if the NF is large, this dimension becomes the increase. And the modular space becomes large, and the very high dimensional space is vacuum. So for the large NF, the relations between these bound states of brightness becomes the highly nonlinear and the extremely complicated. They are not independent, but they are dependent each other. So there will be no complete status of the IRT rhythms with the unity demands per potential. So the IRT requires a new descriptions, and this can be realized by the Seiberg duality. The Seiberg duality, we consider that there's some dual space of the Discord build. Original SUNC SQCD has an app label, and this is the correspond to the electric strong theory with the strong coupling of this gauge symmetry. The colors popular on the Q and Q tildes that are transforms under the SUNC gauge group with NC, and NF for the left-hand and the right-hand is popular. Now that we introduce the dual space, which is the theory equivalency in the impulse part with the magnetic wave theory. So there is a correspondence with electrics and magnetics, and now the coupling becomes the weak. The assigned gauge groups of this magnetic wave theory is SC offset NF minus NC. Now that this magnetic theory still contains the dual Cock build, build the small q and the small q tilde, and also the meson build, gauge singlet, MIZ. Now that this dual Cock build, Q and Q tildes the transforms around the SCU NF minus NC gauge group. But the global symmetry is also same. The magnetic theory is another additional theory introduced on the this electric one. Rather than that, is the alternative UV descriptions of the same IR physics. So there are same IR physics here, but there's another UV physics. The first one is the SUNC electric strong theory, and the second one is the SUNF minus the NC magnetic theory. So both electric and the magnetic theory has the same IR pixel point if we are to learn robot from the UV to the IR. Because if large enough variables, the meson and the baryon do not provide stable descriptions of the modularized spaces due to the complicated algebraic constraints and evidence of refractive theory. So we can introduce the magnetic theory as a new degrees of rhythm small q and the q tilde together with the potential. So now the IR theory can describe together with the additional degrees of rhythm. So now the complicated constraints of the electric descriptions can be replaced by the other condition. But we should match between this electric strong theory and the magnetic wave theory. They describe the same IR physics, so there should be the applied test and matching in the IR level. In the electric theory, the gauge imbalance applied test and meson applied test, which is consisted by the large Q and the large Q tilde. But in the magnetic theory, also there's a meson apparatus, which is the gauge singular, but this is not composed by the small q and the q tilde. So that this meson apparatus is not comes from the dual clock small q and q tilde. So the apparatus and matchings are given by the large q and the q tilde in electric theory, and just like gauge singular in the magnetic theory. Similarly, for the baryon apparatus, in the electric strong theories, the baryon apparatus are given by the NC times the cork build to satisfy the color singlet because of the NC gauge groups. But in the magnetic wave theories, the SU of the NC to becomes the color singlet, the dual corks has the number of the NF minus NC, so the baryon apparatus small b are given by the NF minus NC times this dual character bill. So the operators are matching between these two theories for the Barlow operators are given by the Q of the N and C, and the small q through with the NF minus NC number. Although the numbers of the character and the dual character bills different each other, but the two apply each other transforms in equivalent representations by the Leiber symmetry. So now we also recall the number or the dimensions of the modularized pieces in the IR should be coincide with each other. In particular, the constraints of the length, sort of the dimensions of the Mason operator should be smaller than or equal than the number of the colors that it produces, and also the magnetic theory by the obtained replacement condition. So that both the electric strong theories and the magnetic wave theories show that the same vacuum structures in the IR theory. So for the magnetic theory, there's interactions between the Mason singulars and the dual quark, which is given by the superpotentials, and we can obtain the equation of the motion from this superpotential W with respect to each bills of the Mason singulars and the dual quark. So this does the equation for the motion. And the last two conditions implies that the columns of the dual quarks bills should lie in the corner spaces of the Mason singular matrix. And this dual quark Q carries gauge indexes of the axis of the NF minus NC, so that there is independence of vectors with NF minus NC components satisfying this linear system. So by the linear algebra, the corner space of the Mason singular matrix has the dimension which is rather also equal to this NF minus NC to obtain the non-trivial solution. And by using the dimension theorems of the linear algebra, we can obtain the condition that the length of this Mason singular space should be smaller or equal to the NC. So now the matches of the electric theory relation. Also, because the electric theory, the Mason operator, which is considered by the quarks profile, its length should be equal or smaller than the NC, so that there are sort of consistency between the electric and the magnetic theory. Now how this two different descriptions in the UV regimes can transform, I mean the RG learning over this another scale. So the RG beta functions has the coefficients depending on the NC minus NC and NF. For the electric strong theory, the beta function coefficients is given by the 3 NC minus NF, and for the magnetic theory is given by the gauge part replaces the NF minus NC. So the beta function coefficients are given by 2 NF minus 3 NC. So to have the same IR pixel point, both should be the rather than the zero. I mean the same sign. So to have the same signs of this beta function coefficient, the ranges of the NF is restricted by the following numbers of the NC. This is called the conformal window to realize the Seiberg duality. Now if the values of the NF is nearby the one axis 3 NC, then now the electric theory, because that is B0 becomes small, so the electric theory is weak coupled in the IR theory, but the magnetic theory is strongly coupled because this coefficient become less. Conversely, if the NF is nearby the 3 of the 2 NC, then the electric theory is strongly coupled, while the magnetic theory becomes weakly coupled, because the IR theory is the same with the almost free maybe not just a moment. So the yeah, so this is a confinement scale, coupling and the scale. Yeah, and if that is beta function is zero, there might does not be there are the overall signs of the coefficient and I are the same. So for the first case, if the analysis is equal nearby the duality, then the electric deal is the I know maybe there is some missing point. Why that is just gives the weakly couples. So I will explain the next time. And so the depending on the NF3 losses in the one axis or non axis, there are some DOEs that are weak and the opposite one becomes the weak. So in this video, I talk about the SQCDs with the large NF case. In this case, now the descriptions to the method and the variance that fail, so that we introduced the Seiberg duality to provide the equivalent magnetic description with the additional SU and after the NC gauge theory. So there are the different UV theories which shares the same IR point, and now the spot potentials given by the Mason singlet and the dual curve, and we impose the Price test matching and the modulus pi with the dimensions of studies Mason Price test and the comparable window to realize the duality. So such a cyber duality provides a equivalent descriptions as the same in Brown physics is when the number of suppliers and enough is large in the sports matrix contemporary dynamics.